got his PhD from Purdue University with a chemistry major. With his multidisciplinary background, you can expect Shu Hao as an aspiring data scientist brings value to your company by combining data analytic tools and bridging communications between experts from different fields.
All right. Okay.
Thanks.
All right. Thank you, Daniel, for the intro, and thank you all for being here. If you like alcoholic beverage and also like to try new things, there is something for you. For my capstone project at the Data Incubator, I built a recommendation system of a little mysterious but fascinating alcoholic beverage, rice wine, as known as sake, that based on users' preference of sake's type, flavor, and rice burrito. United States is the top importer of Japanese sake. In 2019, the total exports of Japanese sake to the States were worth $64 million, which is an increase of 100% in 7 years. If you are interested in trying some new sake, this sake recommender app might provide a little help. For the user without any preference, they can start with some popular items. If a user tried a popular sake and liked it, they can find other similar items as well. If a user does show preference of a particular sake, the system returns similar items based on sake's features. For example, I want to get similar items to one of my favorite, Dasai 45, which is clean, dry, and pairs well with sushi. So we select Dasai 45 and search. And then we get the sake recommendation with highest similarities. All the recommendations are clean and dry sake, represented by these two values being negative, with similar ABV, polishing ratio, and rice burrito. I have tried Sawanoi and Urakasumi before, and in my opinion, they taste similar to the sake I like, Dasai 45. The sake data used for this content-based recommendation system are mostly obtainable from sake labels. They include useful information such as rice polishing ratio, sake meter value, rice burrito, alcohol content, and acidity. These features are related to sake's flavor profile. By web scraping, I have collected data from about 10,000 sake products among 1,600 breweries. Here is the demonstration of how this app works if only two features are considered. When a user selects a sake for recommendation, the system returns similar items based on calculated similarity. If no sake is selected, the system will return popular items from each sake flavor category. I hope this tool helped you find your favorite sake. If interested, please visit my project website to give it a try. Thank you.
That's great, Joel. Thank you. Any questions?
One here for me. This is really, really cool. Do you have any plans to expand this beyond sake, or will this be limited just to sake and open source data sets? I was curious if there's a way to overlap it with other types of alcohol as well.
Yes, that's definitely a good question, and thanks for asking that. So I think it is possible to include this into like already existed database like red wine or white wine, and then we can have these user data, and then to see if we can have some kind of collaborative filtering, and so then for like specific white wine lovers, and they can choose related to a specific type of sake. So that is definitely something I'm considering in the future.
Hi, Chao. I have a question. Thanks so much for the presentation. Did you have any problems with data sparsity? So were you able to find all 4 properties for all the drinks, or did you have to work in imputation?
Yeah, that is a very good question. So so for this app to work, so I specifically filter out the data that doesn't have a sake meter value and acidity. So these two features that is the one I weight the most. So so from scraping 10,000 sake products, so there are about like 5,000 left. So which is not too bad to have these two features available. Yeah.
Hi, this is Cliff Emmons. Just curious, can you tell us a little bit more about what you did in order to, create, the initial clustering methodologies you used, and then how you translated that into making a faithful model? And can you give us some, I guess, let's start there, and I have one follow-up question.
Okay, so then I will show this plot. So basically, so the sake liter value and the acidity, these two features are by some Japanese research from the Japanese breweries, and so they map these two features to these two features called amakara and notan. So which amakara means then if you have like have a minus value, that means you have dry features, and then if it's positive value, it's sweet, and then for the notan, that means if the acidity, like if this one is low, that means you have a clean profile, and if you have like a larger value, you have rich profile. So in this case, I basically use Gosai similarity to map this region. That's just for these two features. So for other features like the alcohol by volume and also with the polishing ratio, I first scale them and then to center them as the features from ranging from -1 to 1. And then for other categorical features such as the rice burrito, I use the one-hot coding to incorporate the model and to generate a feature vector.
Thank you. And I guess, do you have any data on how well the experience of people are to the recommendations? How well is the model fitting to people's actual, you say that this is the right one. In the end, it matters like how people perceive it. So I was wondering if you have any data.
Okay. Okay, understood. Thank you for this question. So unfortunately, I don't have this right now because so far I haven't yet created a user reviews profile. But that is the next step I will start to build. So after I build this user item and matrices, and I can then choose performance metric to gauge whether my recommend system is doing a good job or not.
Thank you.
Thank you.
Could you summarize in one sentence what is the biggest challenge in this project? You convert some of the features, but after that, do you feel any difficulty?
Yes, so actually the first difficulty is that I parse so I scrape this data from a Japanese website, and so then the first thing the first challenge will be like converting like the Japanese to Romaji, just like easier for like people not familiar with Japanese to use the system. So that is the first challenge, and I need to use some Python package that includes some NLP techniques, and so they can like transfer Japanese into Romaji, but that is not perfect. So there's a lot of data cleaning I need to do. So I think that's the most challenging part. Yeah.
Well, that's great. Thanks, Shubham. Any other questions? I've never seen an app that makes me want to drink so much. But thank you. It was really great and a creative project. Thank you.
Thank you, Daniel.
All right. So next up is Wandi Yu, who's going to share with us a YouTube trend app. Wandi is a PhD student from Texas A&M University, majoring in atmospheric sciences. She has 6 years of experience analyzing big data using statistical and modeling methods. And we can see your screen is fine, so take it away.
Thanks, Daniel. Hi, my name is Wendy. It's my great pleasure today to have this opportunity to show my capstone project. Many people are interested in earning money from their YouTube channels, and they pay for earning small views. Imagine if you're a YouTuber who wants to create a new video, you be concerned if the idea you come up with will be popular. After finishing making the video, you also want to know what's the best time to publish it. My goal is to provide a reference for YouTubers on the popularity of different topics in the video category of food. As a YouTuber, you can input one or more keywords or topics or just press the title you want to use. For example, you may want to publish a video names best chocolate cake in the world. Our system will first give a short, conclusive report here. This short, conclusive report. The views rating indicates the possibility that this video has higher view numbers than usual, and the likes rating is the possibility that your audience clicks the like button and leaves a positive comment, so they may want to watch your new videos in the future. We give a fair prediction for both of the metrics, which means that at least you are now losing your audience by publishing this video. And the popularity of your video may depend more on other factors, such as how you describe the key content in your title. If you think this result is acceptable, you can check our suggestions on the published time. But if you are not satisfied with this prediction, don't worry. We also provide a detailed report for each of the keywords in our titles that are related to food, cake and chocolate in this case. By switching from the text, you can choose to look at the history trend shown by the blue part of the line and the future prediction, the red part of the line, of each of the keywords. You may find that the popularity of chocolate has a significant cycle, and it might not be a good time to publish a video related to that. However, the popularity of cake is always robust, so maybe you want to go back to the home page and try to test on a different flavor of the cake. If you are interested in how the app works, I also include an information page, including the data and the metrics and machine learning model I use, also the model performance. Now the PSNR for this model is only 0.46, and I'm still working harder to improve it. So if you have any suggestions or questions, please let me know. Thanks for your attention.
Thank you, Wendy. Any questions for Wendy?
I had a question. So it's beautiful to have seen this grown from the original idea way back when. Something on my mind was, what if I search for something that's not food?
Okay, I'm actually thanks for asking. So we will try to have time. And it will tell you we did not detect any food-related keywords or the corresponding video never hit top 50 over the last year. Because in the before page I said we only get the top 50 videos per week from the last year.
Hi, question. Really cool app. So I've worked with YouTube data in my past extensively. I know the limitations of the API can be quite cumbersome. Do you think this is something that, if given the data access, you would be able to expand beyond just food or beyond just the top 50 videos per week? And how do you think that would affect your models?
If I get more data than 50, I think the results must be better. And switching from different categories, I think I may need to work a little bit on the NLP process of this project. And I thought about switch to like game category in the future, because I think the trend of game is very predictable. And I haven't thought about other categories, but I think game might be a good choice. Thank you.
Hi, this is Cliff. Very nice project, very interesting. I am a little curious if I understand correctly. So the correlation is relatively low, less, 0.46, less than a coin toss, correct?
Yeah.
Yeah. So could you tell me, based on what you've done so far, what are your ideas that you can do to try and get this, better than a coin toss?
Maybe go back to the project we showed before. And for example, some people, over time, people might be interested in this topic, and they are tired of it. And after a long time, they get the interest again. So I think that's the case. And also for many topics I didn't show today, they have actually an increasing trend. That's another factor that I think I can predict it. And also the autocorrelation. Maybe we can catch some tail of the very popular thing in this app.
Thank you.
Okay, I have a question. Have you ever take a look at the entire sample space? A question about the 50 videos. Can you make sure the 50 videos can help you draw any meaningful conclusion? Because can you make sure how many videos do you need for each category to help you draw some meaningful conclusion?
Yeah, that's a very good question. Now I only have 50 is because the limit of the API. I believe in the future, if I download more data, the performance must be better. Yeah, thanks for
These are great questions. We have time for one more, if anybody has any.
Actually, hi Wendy, great project again. I have a question that you didn't mention. You accounted for the, I guess, positive comment, and I saw there was like a sentiment index on your. Just go into a bit of detail. Was that like a summation per? Yeah, where did is the sentiment related to the comments, and how is that derived basically?
Oh, so I did the sentiment analysis using this radar sentiment package, and it returns an index. I normalize these indexes and multiplies the index of life to generate this total.
Is that over all like comments?
Yes, yeah.
Okay, thank you.
Great. Well, thank you, Wandy. It was a great project. Again, making me hungry. All right, so we'll move on to the last presentation, but not least by means. And so Ying Wan is going to share with us her Airbnb host tool. You can go ahead and get your screen up on the share. There you go. And so Ying is a growth-driven data scientist and strategy consultant with expertise which spans the fields of business strategy and AI-driven enterprise transformation. She's passionate about data science and its applications to shape critical business decisions across the globe, and she holds a PhD in operations research from Cornell University. So thank you, Ying.
All right, thank you, Daniel. And good afternoon, everyone. Again, my name is Ying. I'm very excited here to share with all you my Capstone project. As the Airbnb community has been growing tremendously in the past few years, a lot of people are thinking about being a host. And same for me. Recently, I've been thinking about maybe turning part of my house into an Airbnb listing. But the first question I kind of like trying to tackle is what's the proper baseline price for it? And this is the motivation really behind building this tool for it. And this is what this tool look like. As a user, you will be able to input a few pieces of information according to your listing. Let's say, for example, I have an apartment, it's a one-year apartment, which is located in, say, one of the most famous neighborhoods here in Seattle, Hyde Marketplace. And apparently the model feels having a coffee machine is pretty important for the price point. So let's say, yes, I'm going to buy a coffee machine over there. And I'm gonna just leave everything here as default and doing this calculation. And here is what the model would recommend to us. It says like the recommended baseline price for my listing is roughly $120 per night. And besides that, it also calculates the top 5 similar listings that's currently up there in Airbnb. You can go ahead and click. And this piece of information is helpful in a sense that first you can double check whether the recommended price is on the ballpark. And also you can explore your competitors' listing, right? See what other amenities or features they're providing, but you're not. So you can think about adding those features as well. So far this model is really based on the Seattle area, which I live. If you're interested, the data are extracted from a public available data set, like website. They have, there are about like 8,000 listing information for Seattle area, covering the property information, the neighborhood, the hosts, and the guest reviews, etc. So other information are processed, cleaned up, and then dropped into a few machine learning models. And so far, my model has been giving a reasonable accurate prediction and also calculates the important features for the listing. And we pick those top ones and actionable ones and actually use that as the user input in our landing page. For example, here, the location matters a lot. And also, if you are the host, probably you want to make your list to be instant bookable because the model thinks having this feature is it's helpful for your listing price. So yeah, GitHub link here can give you more details about modeling. And again, if you have more thoughts, questions, and interest, definitely connect with me. Thank you very much for the attention. With that, happy to take any questions.
I have a question. Do you take as an input in your model how often a place gets booked? Because that would seem to matter, you know, for if you're looking for an optimal price as opposed to just a listed price.
Yes, if I understand your question correctly, so the number of reviews, or well, I have to tell this way. So the model input kind of like proxy what you're saying, the number of bookings, like historical bookings. I use the number of reviews. And that's actually one of the problem here with this public available data set. That is, I don't really have the actual, this place was rented out and how many times was rented out, that piece of information. Which is a drawback. I would like to improve the model if I can get more high quality data. But with the current data set, what I did is, utilize other pieces of information like the historical reviews, the number of reviews, that piece of information to really calculate a proxy for that.
Hi, this is Cliff. Great project. Definitely something that I think even some friends who currently book their properties with Airbnb might be interested in. Could you repeat again when you said you used the public data? Okay, isn't it just off of the Airbnb, or can give some more color exactly where you were saying you were pulling the public data from?
Yeah, of course. So if you can see here, this is actually what this called, as the website is called Inside Airbnb. what they are doing is they kind of like regularly scrape the listing information that's showing up on the Airbnb website, so that so which information you will be able to see as a user when you are looking at Airbnb's website, like that website like scrape those information. But like I mentioned, one problem with that is it doesn't really have whether this place has been rented out and what actual price it was rented out. So that's one of the issues I would say with this data quality.
Thank you. A little follow on there. You said you felt your model did pretty good as far as prediction, but you really didn't give us, a sensitivity, on specificity. Could you please put it in those terms, please?
Oh yeah, sure. Yeah, maybe I should have like printed out those numbers. So in the sense of the this plot is showing the predicted price versus the actual price for my testing data. This is in terms of R-square, it's around 0.7. I have to admit it's not good enough, but given my data set is only 8,000 for the Seattle area, I would say it's reasonable. And in terms of the MAPE, the like percentage area-wise is roughly 25%. So yeah, still a lot of space for improvements.
Thank you very much.
Sure.
Great questions. Any more?
Yeah, thanks a lot for the presentation. That was great. I was wondering if the features that you used there are the ones that were provided in the original dataset, or did you do any feature engineering? One example that comes to mind is to check whether other Airbnb places exist near the ones that you are looking for, with the thought that usually places of high density in Airbnbs are usually the ones that are like touristic attractions or central downtown, and that also might be driving for the listing price.
That's an excellent question. That's actually one thing incorporated in my future plan. For the current model, you're right that I haven't done like too much of the feature engineering, like adding the tourist location, calculating the distance between the tourists, like attractive locations versus the your input place. It's more like utilizing the neighborhood information. So because since you have the neighborhood information, you also have other listings that's within this neighborhood that can like in a less like indirect way will tell you the price, how sensitive price in this location, in this neighborhood. But yeah, in my next step, that is to actually calculate selecting a few very hot spots in Seattle, calculating the distance and adding that as one of the features that I think that should be interesting to look into.
Thanks.
Thank you.
Great. Well, thank you, Ying. You make me miss Seattle.
Thank you.
All right. So let's see. I think we'll move into the next phase. Unless does anybody have anything else they want to add or ask? Great. So this part, we'd like thank you very much, everybody, for the presentations, and thank you for everybody for staying and participating and watching. Especially our hiring partners. And so we wanted to take a second and let the hiring partners introduce themselves. And so maybe if we could start just there at the last question, is if you could let us know a little bit about yourself and Foursquare.
Sure, yeah. As you said, I work at Foursquare. My name is Petro. I'm a senior data scientist there. I've been with the company for about 3 years now. And I'm working on machine learning and data science related algorithms on the product that we have that we called places or venues, as we internally call it, which is essentially has to do with the database of places that we have, places that people visit that extend to everything that is visitable, let's say, and we try to attribute features to these places like firmographic data that include address, city, phone numbers, the category of the places, which then is used for other products that we have downstream, such as assigning foot traffic data on these locations and checking information as we call it, and visits that will give us further insights. So my part is mostly working on making this database automatically ingesting new sources and merging the information that we get from different parties and from our first-party users in order to provide more enhanced versions of these places and fill in any missing information as possible.
Great, well, thank you, and look forward to having more of a discussion in the breakout rooms. So next, Cece, please circle up.
Yes. Hi everyone. I'm Cece, and I'm actually a TDI alumni who was in the program with Rich and Rob 2 summers ago. I'm currently at Circle Up, which is looks to provide credit and capital to small early stage consumer packaged goods brands, and we use data to do a lot of the sourcing and diligence. So to have a very data-driven approach. And currently, we are looking for some technical roles, but I'm still trying to convince them that we do need more data scientists. So I'll keep you guys posted.
Great, thank you. All right, and Cliff, you have some great questions. How about you introduce yourself?
Thanks, Daniel. Yeah, so I'm Cliff Emmons. I'm the CEO of IIoT Oxys, and we are a company that's focused on digital transformation, definitely in the smart manufacturing area. We definitely cater to biotech, pharma, and med device companies, especially those in the Cambridge, greater Cambridge, Boston area. We also have a pretty substantial effort in structural health monitoring as well. So the areas of interest that I have are data scientists and machine learning algorithm engineers that are focused primarily on being able to use traditional forms of signal conditioning that comes from various types of sensors. We also do deal with image data, maybe less so NLP methods, but we do have even opportunities for applications there. We need good, strong analysis that can lead to good creation of things such as feature engineering that can lead to robust models. The idea is to create digital twins for manufacturing operations groups that can be used to optimize their productivity. So very impressed with the presentations today, and it's nice to be here tonight. Thank you.
Thank you. Thanks for joining. And Joe with All Inbox.
Thanks, Daniel. So I'm Joe Isabello, lead data scientist at All Inbox / Media Group. Just went through a merger. We are an email list management and interactive advertising company. So we constantly are looking to find the right ad for the right person at the right time through the right channel. So we have a wealth of data we like to wade through, and constantly are applying new techniques for testing, modeling, and getting information and presenting it in a manner to which stakeholders can use and leverage. I was very impressed with the presentations tonight, so thank you for having me. I love being here.
Great, yeah, thanks for joining. Let's see, did I happen to miss any names of our visiting hiring partners?
Hi, Carl Gerbasic from Peregrine Advisors here. I'm a TDI alum from 2017, so I know what all of you are going through. What we're doing at Peregrine Advisors is we're operating in the space where data strategy, data management, and data science interconnect. For now, we're doing it in the federal government space. We're a small DC-based startup, consulting startup, but we like having data scientists on board because when you're building your data strategy or your data management systems, you really need to understand what your end user is going to be doing. And the experience that data scientists bring, not just having a conceptual understanding, but having the hands-on experience understanding with what that end user is going to be doing is really crucial for building up the higher portions of that hierarchy in the data strategy and data management. Our current primary client is the SEC, so there's a ton of data that is going to be available to us as these projects move forward. So not only is there going to be that opportunity to kind of develop those systems out, but also once those systems are developed out, really get access to some of the largest repositories of data in the world.
Exciting. Great. Thanks. I see, Josh, did you join you with the same group?
Yeah. Hi, my name is Josh. I am also a data scientist working with Breakout Advisors under Carl. So I was also part of the TDI, the first all-online TDI cohort back in April. So yeah, there's hope for you guys if you're concerned about the pandemic and things. Yeah, there's hope for finding jobs, and the job market is open out there. So yeah, looking forward to talking to you more in the business session.
Thanks, Josh. Yeah, we definitely need hope. But this has been great. This has been a good sharing opportunity. Anyone else that I might have missed? All right, great. So let's see. Next phase, we're going to have an opportunity to all get together, just have a little bit more detailed conversation in a smaller virtual room. I am not the person pressing the button, so if anything goes wrong, please don't blame me. But I don't know who is the person pressing the buttons. You want to let us know how this is going to work?
That is me, the button pusher behind the scenes.
Thank you.
So thanks, Daniel, for running it so far, but now I get to take over. So I'm about to split us up into 5 groups. We'll have one of the hiring partners in each group, if I did this right, as well as about 7 or 8 students. So we'll give you probably about 10 minutes or so per group to just discuss a little bit. So all of the students, whether they did a presentation or not, have been working on a capstone project, so I'm sure all of them will be happy to tell you about what they're working on. But also, I'm sure all the students would be very interested to hear about what life is like at your particular companies for the hiring partners. We'll give you a little warning, and then by every 10 minutes, we will be shuffling the hiring partners around so that everybody gets at least a brief chance to meet everyone else. So I have opened the rooms. You should now be invited to join, and click that join button and have fun.
I don't think you would put me in a room, Rob.
I don't have a choice. I have to put everyone.
Oh, okay.
You guys, if you just don't join, you can say here, Kide, did we get you into your room?
Oh, there it is.
Okay. Yeah, there's apparently no way I can. I guess I could have made another room that we just go into, but
yeah,
the way to
I'll just click the later button.
Yeah, me too. Wait. So, recording pause. Okay.
Yeah, I turned that off because I want to chat.
Yeah.
After
so I guess we had some technical difficulties with the YouTube meeting. It's in there. Oh, okay.
Hey, Jamal, did we not get you into a room?
Oh, sorry, I got disconnected from everything. Me in break room 2.
Were you in 2?
Yeah.
Okay, let me send you back to 2.
So if we're streaming on YouTube, this part probably doesn't need to be streamed.
yeah, I hope, well, we communicated that we did not want this to go live with breakout rooms, so it should have ended at the inception of the breakout room. So I don't know if Colleen is still